Okay, everybody, it's good to see you. I hope you're having a wonderful weekend. I noticed that some folks were struggling with a little bit of getting started on the homework, and so I wanted to create this little video so that those of you who are still feeling frustrated would have someplace to turn for kind of like a walkthrough. So with this in mind, let's think about what we're doing. We're trying to solve a system of three different equations. We need to find one set that satisfies all three at the same time. This is something that we've done with like plugging and chugging. You just like guess some numbers, guess an x, guess a y, guess a z, and see what works. But as you know, that takes a long time. There are literally infinite combinations of things that you could come up with, and especially when the answer is something really confusing, like something like 9/10, like it's going to take you a long time to guess that, and to guess all three correctly at the same time is exhausting. So there are other ways to do it, and the one that you all have relied on the most is stacking the equations on top of each other and then manipulating one so that it mutually eliminates one of the terms. Like if you have a positive 2x and a negative 2x, you can just add those equations completely together, and the positive and negative 2x's will just disappear. That's great and that's helpful, but when you have three variables, that becomes an even more difficult task. And so there's another way to do it called substitution that you've learned but that you all are the least comfortable with that we're going to jump in and see what this looks like. The most important vocab that you need is the phrase to solve for blank in terms of blank. And what that means is you're finding what something equals even though you don't know the exact number, like you know it in terms of another variable. So for example, x minus y equals -4. Okay, so thinking off the top of my head, like it could be 0 and 4 because 0 minus 4 would be -4. It could also be 1 and 5 because 1 minus 5 would also be -4. So there's any number of things it could be, but one thing that I do know has to be true, and I can do this with some pretty basic algebra, is that x has to be equal to y minus 4, whatever it is. So if this is 5, then that will be 1, which makes sense. 1 minus 5 does equal -4. So this relationship, I have actually solved for x in terms of y. That may not seem very useful right away, but it is. It's super useful because what this means is that since I now know what x equals, I can jump up to something like this, and I can plug that value of x into this. So instead of saying 2x plus y plus z equals -2, I can say 2 times that entire expression, y minus 4, plus y plus z equals -2. And so now, if I distribute this out, 2y minus 2 times 4 is 8, plus another y plus z equals -2. I've got some like terms that I can do, like I can add this 8 to both sides, and I can also combine these 2y and that 1y. So I would get 3y over here, 2y plus y, and plus z is equal to -2 plus 8 would give me a 6. Now, this, again, is like not a full finished equation, but I can solve for one of these variables. And it doesn't matter which one, but since z is already by itself, that's what I'm going to choose because it's pretty straightforward. It's like exactly what I could do in the fewest steps. I like to keep things simple. So in this case, I'll subtract out the 3y from both sides, and then I find out that z is equal to 6 minus 3y. Again, I've solved for z in terms of y. So over here I solved for x in terms of y. Now I've solved for z in terms of y, which means that just like this x can now be replaced, now anytime I see a z, I can replace it with this entire expression. The reason this becomes super cool is apparent now, because in this last equation, what I see is, oh, I have one of those x's that I already found, and I also have a z, which I've already found, and so I can replace this z with that expression and that x with that expression, and so my final answer over here becomes y minus 4 instead of the x, plus 2 times y minus, and then I'm going to put this in parentheses. Do not forget to include that minus every step of the way. Let me separate these equations real quick. Minus 6 minus 3y equals 4. So then, simplifying a little bit, first I'll distribute this invisible -1 that's outside these parentheses. So I'll get minus 6 plus 3y equals 4. Bring down the 2y. Bring down the y and the minus 4. Now, it's just a matter of combining like terms and finishing this last little bit. So I have a y and a 2y and a 3y. So 1y plus 2y plus 3y. That adds up to 6y. And then a -4 and a -6 add up to a -10. equals 4. I can add 10 to both sides. I get 6y is equal to 14. And then from here, if I divide both sides by 6, I'll find out that y is equal to 14 over 6, which can be reduced to 7 over 3. And that is a little bit of a nasty answer, but it's great that I found it because now I have an actual numerical value for this, and I can go back over to these checkpoints, plug in the 7/3, and find my final finished answer. Let's do that right now. So, if I come back over here, I know that x is equal to y, but instead of y, I can use 7/3. So 7/3 minus 4. You guys have done this really well many times, converting to a common denominator. 4 in terms of thirds. You can do the transformer T that I saw you guys use. I am pretty good at doing this in my head, so 3 times 4 is 12. That'll be 12/3, because 12/3 is the same as 4. 7/3 minus 12/3 would be negative 5/3 for x. And then for z, same scenario. I know that z is 6 minus 3 times y, and since y is 7/3, then I know that z is going to be equal to 6 minus 3 times 7 over 3, because 7/3 is what y is equal to. This is the same as 3 over 1, because it's a whole number. 3 times 7 is 21/3. That'll reduce back down to 7, or you could even think of it as canceling the 3's. So z is going to be equal to 6 minus 7, which is negative 1. And so, I did eventually find all 3 variables, even though the checkpoints along the way were messy. They involved finding x in terms of y and finding z in terms of y before I could ever get to a final full number. But this is great because even though it took me a while, it's much, much easier than trying to guess 7/3, negative 5/3, and negative 1. I am good at this, and I probably never would have gotten that just by random guessing. That's a weird combination of things. This is why I prefer the substitution method, and this is why it's really important that you guys are familiar with the vocabulary of like solving for x in terms of y. All right, with this in mind, I'm actually going to do another video that shows just the very first step of how you would solve the first homework problem that you have.